My name is Wolfgang Hall, and with me here today is Maxime.
I'm Maxime Chambroy. I'm the architect at Open Source Integrators.
Great, and today's topic is going to be material requirements planning done right. And a new topic in the industry is DDMRP. What is DDMRP, Max?
DDMRP stands for Demand-Driven Material Requirements Planning, Wolfgang, and it's the new way to manage your warehouse and supply chain.
Great. And for those of you who are already very familiar with the topic, you know that DDMRP is an evolution from MRP, which is Material Requirements Planning. And this has been around for quite a while. It became really popular in the 70s and then over the next decades. And it's pretty much found in any enterprise resource planning system today. And what you will also know is that there's often a lack of trust in those systems. They are used with spreadsheets in order to compensate for some of the automated tools that are not always deemed reliable by their users, or users don't have the confidence, so they actually add to these processes and sometimes actually cause problems by doing that. But another problem with the MRP systems is that they are all connected and not necessarily decoupled. And this is one of the big strengths that Max will talk about. Do you want to give us a little bit of an overview on DDMRP?
Thank you, Wolfgang. Let me show you how DDMRP works.
Today we're going to discuss DDMRP, Demand-Driven Material Requirements Planning. And our agenda is going to focus on the background of the DDMRP. What's the main concepts behind it? So we're going to cover the 5 components. We will define what's a decoupling point, a buffer, and we will discuss the net flow equations before concluding this webinar. Some background about material requirements planning. So MRP was designed in the 50s. It basically revolutionized the manufacturing industries to a point where it's now included in almost every ERP systems. Problems with the MRP. Today we have 70% of companies using spreadsheets because they don't trust the output of the MRP engine. And also one thing is MRP was designed in a context where the supply chain was shorter, simpler. Today supply chain is worldwide and people want everything right now, so it's real-time demand. And products are here for a couple months, not even years anymore. Other issue with MRP, it's based on forecast, and forecasts are by definition inaccurate. And we also have long variable lead times. So we have high volatility in the lead time from suppliers. The more details we want to have in this forecast, the more errors that were introduced. And the MRP tries to connect every component, and the safety stock is static, so it's a fixed value and it doesn't adapt over time with the demand that companies may experience. Another issue with MRP is due to this tightly integration, not only within the company, but also in regards to the whole supply networks from the distributors to the manufacturers. And so everybody along the chain try to bump every quantity to have some margin, to have some security. So the demand signal is distorted. We tend to procure more quantities to give us some days of protections. And the demand is so distorted, but also the supply and the flow of products gets distorted as well. And it's these distortions spread out across the supply network. So how DDMRP tries to solve those issues? DDMRP focuses on the flow and how to protect this flow of information in the supply network and the flow of products downwards within that same network. And the thing is, by taking care about the flow, it reduces the cost, which is not true if you only focus about the cost. The flow is not going to get better. So to get back to our schema here with the supply network, by positioning a buffer here between the component and subassembler, we try to minimize the spread out of the propagation of the distortions upwards and downwards, because the buffer is going to absorb that distortion. And so one of the first steps of a DDMRP implementation is to position those decoupling points so that you always have inventory products available at that point in the supply network. So as I said, first step about the DDMRP is positioning. So where should you put your buffer in the supply network or within your supply chain? Second step is how to compute the buffer profiles and how to define those three zones, the red, yellow, and green zone. Third step within the phase of protection is how to set buffer adjustment so that buffer gets dynamically updated. And that's basically the end of the configuration part here. In terms of operations, we have the last two steps. So first is the procurement team that should take care of the buffer and drive the demand. And last one is by your color-coded signals, the whole team within your organization can execute the planning through visible KPI and collaboration.